I will start my presentation then. Again, good afternoon. I'm very happy to be here today. It's for me an honor, I have to say. This presentation, as you know, is about drones for agriculture. I'm assistant professor at the Information Technology Group. I'm also the principal investigator of the Social Drones Lab. And this presentation basically is organized in three phases: a little bit about who I am and what is my my current research and activities, how we can use drones for agriculture, and there is a typo there. I apologize for that. Which applications we can apply drones. So a little bit very fast, my short biography. I start work with the UAVs. In this presentation, by the way, I might use both the term UAV or drone because I mix them often. For me are the same, but of course there are specific difference between one term and another one. So I started working in drones in 2007 while doing my master in computer science and electronics engineer at the University of Rome La Sapienza. When I finished my master thesis there, I was invited to join a research group in Madrid. That it was in 2011, and I continued to work with, I continued my research on drones. In this university, I did my master and my PhD. On 2015, I joined the Carlos III University of Madrid, where I was assistant professor. And finally, it was always my will to one day to join Wageningen, and that was possible in 2007 and 17, where I joined the laboratory from geoinformation and remote sensing. And later on, where I was postdoc for 2 years, and then later on, in 2019, I joined the Information and Technology Group, first as a lecturer and then as a research, as an assistant professor. So my research at Wageningen is basically bridging the gap between drones and people. So the main idea is to approach airborne technology from us. So how I do that? I actually combine information provided by the cultural practice from people, mainly from the farmers, for instance, information that they know by heart and they are used to apply, with sensorial information provided by the drones, mostly machine vision and machine olfaction. So with this information, I built artificial intelligence systems then can later be embedded in autonomous drones that can autonomously scout fields and provide readable information to no expert user. Basically, what they can provide to the farmer is a to-do list that is something simple and easy to trigger. My research line is also aligned with education. So I have developed MOOCs. There is already a MOOC running for 3 times. That is drones for agriculture, that you can find it in EDIAKIS. And there are plans, of course, to continue and do a series of MOOCs about drones on agriculture. So now we are already working on drones for agriculture too. I also like to develop courses where I focus, where I can teach the students how to actually program a drone. So the goal is a little bit to give a step forward, and that right now lots of drones are still used remote pilot by experienced pilots, and what we want is to achieve a high level of autonomously. With this, in the end of the last year and the beginning of this one, a new lab was set up that is a facility from the information technology group that it calls the Social Artificial Intelligence Drones Lab, the SAID Lab, or also in short, the Social Drones Lab, whose goals are designing AI approaches that translate raw drone data in practical information, but also to explore human-drone interaction tools, channels, boost drones technology education, as I mentioned before, through MOOC education, through online education, and many other things. In general, use drones for good. Also important to say, I will go back to the previous slide, is that currently this facility is composed by 3 PhDs, 15 master students, 2 bachelor students and a research assistant. It counts with 5-6 drone platforms that can be programmable, with a high performance computer, also a water drone that it was custom built, like other instrumentation and tools, like for instance, 3D printer machines, etc. It's also a facility that is already is already supported and backed up by a large network of worldwide knowledge institute, both from Europe, Americas, Asia, etc. And today, and finally, we are going straight to the point. So today, what I want to give you is a short introduction to aerial surveying. So I have this short course, the not so short introduction to aerial survey, where you are going to learn a little bit about acquisition, data processing, data analysis, variables, and finally applications. So we can have a look on several UAV platforms that can be applied for agriculture. Of course, these platforms are the platforms that I used to work with. That is based on my experience. There are some others, but I believe that this is already quite a large number of platforms that we can review. So you can see that we have the first platform that is from a German company called Air Robots. This platform I worked before in the past, so I worked while I was in Spain. It's a large and a very professional platform with that you can have ship payloads up to 5 kilos. The other platforms are more platforms that I'm currently working mainly from the brand DJI, so the Matrix, the M210, RTK, the DJI Phantom, and the DJI Mavic. So all these platforms can be shipped with cameras, or most of them have already available a camera. Most of the cameras that I used to work are true color, that is RGB, but also a false color, that is multispectral cameras that can provide us the green channel, the red edge, and the near channel. You have platforms of all kinds, according with your economical availability. You can choose what you want. So there is also sometimes a trade-off between the capacity of the platform, how good it is, with the price. So if you want to spend less than 2,000 euros, you can get one of the Phantom models. And that the one that I'm showing is not the last model. The one that I'm showing is the Phantom 3 that has a camera, for instance, of 16 megapixels. On your right, you can see the Mavic. That is a Mavic 2, DJI Mavic 2, and that is a platform that together with the multispectral camera will cost you less than 4,000 euros. The inbuilt camera of the Mavic 2, for instance, has 20 megapixels of resolution. And then finally, you can, if you want to spend less than 1,000 euros, but still you want high quality imagery, you have the Anafi, the Parrot Anafi. These, of course, you will say, okay, but how is possible that less than 1,000 euros, but still 21 megapixels camera? Let's also see the timeline when these platforms come out to the market. So the Phantom 3, it's an older platform. Then the Mavic 2 come out, and today with sensor miniaturization and the developments in the airborne technology, you can acquire cheaper platforms with high performance. More sensor payloads, also based on my experience, but yeah, I'm also working with electronic noses. So also the electronic nose is a system composed by different gas sensors. So they are used for different applications. I'm going to mention that later on. Some of them were developed and designed by companies and cost like dozens of euros, while others cost less than 1,000 euros and are custom built. Other hand instrumentation to bring to the field, it's nice to have a nice tablet where you can monitor the mission as a pilot. And also a wind meter to measure the velocity of the wind. Actually, everybody calls it wind meter, but the official name is a nanometer. And then a lux meters to measure the intensity of the light in lux. For what data processing concern, it also depends what you have available. If you can get a very professional and high quality software for processing the data, and transforming the UAV pictures, UAV image in a UAV product. This is, you can have like from RGB image, you can have an orthomosaic, you can have a point cloud. So there are different types of UAV products that you can achieve with single UAV image. So if you at a professional level, that's one of the software that are mostly used is Metashape Photoscan. That is a Russian software. It's quite robust and is, let's say that it's used usually in professional photogrammetry. Recently, not recently, but a couple of years ago, there was an initiative of the open source community, and they developed a similar software named Open Drone Maps, which you can achieve the same results. But of course, this is open source, so it's for free, and it has a large community supporting this project. So it's nice. It's nice when you have less economical availability. So these are some of the products that you can get. So you can see that you have a point cloud in the top right, orthomosaics on the right. And of course, if you want to give the step to real time, then you should work with robotic operating system. So again, so most of the time for data analysis, you can use both Python. There are tons of libraries and open source projects that are handy for processing your data and deriving the variables that you are looking for. And when you want to give the jump to real time, so that do real-time data processing, then a good solution is using robotic operating systems that again has a bunch of libraries that you can use already to make not just autonomous navigation, but also data interpretation. Okay, now let's see some of the applications where we can apply all of these things. So to be easier to understand, I'm going to focus on the crop itself. So we have apples, pears, spinach, cauliflowers, and grasslands. So we are going to start by the apples. So a nice application that we can see here is, for instance, use the drones for ripeness assessment. Here, what we are interested in seeing is combining both UAV image with olfaction. So in order to achieve that, we have developed a simulator, a simulator of the gas that is emitted by the apples when they are ripe. That gas, that chemical compound, it's called ethylene. So when our fruits are achieve a mature age and are ready to be harvested, they emit high concentrations of ethylene. So in order to study what is the best position to monitor this ethylene gas within orchard fields, mostly orchard fields, apple and pear fields, we have developed this simulator. We have used a robotic operating system, and we have used GADEN, that is already a gas library where you can simulate gases within robotic operating system. We have also, we did already lots of field work for calibrating the sensors. So putting them on the field and trying to understand the behavior of the sensor itself before putting it on the UAV. And of course, we have a wide experience acquiring imagery and processing it, so that it was more straightforward. And then, of course, all the complexity of make the data fusion between image and sensor data. So that is also quite interesting. You have 2D, 1D, and 3D and 4D. So you jump from dimensions, and then you have to derive which part of the crop is ready to be harvested, and which quantity of the crop should be placed in different places. Another application that we have been working on is on flower blossom estimation. So it's important for the farmers to have a good understanding during the spring which flowers they have to remove from the tree in order to get a good balance between flower and fruit. So we are using UAVs to detect these flower clusters and provide detailed and fine maps to the farmer with the areas that they have to apply chemical, hand, and mechanical timing for the flowers. Another nice application is again in orchards. In this case in pear orchards, we jump from the apples to the pears. So the farmers need to have a good also a good balance between the tree volume and height. So it's important for them to prune the tree from time to time to get this balance. This balance. So we have tested in this application what was the difference between developing a point cloud that is derived from the UAV imagery from a terrestrial laser scanner. We have compared, and actually we got a very nice correlation, which means that the UAV can be used to obtain the elevation, the height of the trees in a wide orchard. Another nice project, and now again let's jump from the pears to the spinach. This is a big project that it was in collaboration with a huge plant breeding company, which name I cannot say because of confidentiality. And in this study, it was composed in 3 stages. The first stage was to determine what was the males and the female plants, and also the most emergent plants at a qualitative level. The second step of this project was, okay, once we understand what are these areas, females, males, and which plants are emerging better, we need to count them. We need to have a good understanding how many plants we are talking about. And then we need to go lower to the plant level and count the phenotypes from the plant, different phenotypes. There is the area of the leaves, the number of leaves, the height of the plant, etc. In this project, I did not say it before, but of course the different techniques are used. You can have a very good understanding which techniques were used in this project because all of them have a related publication. Then I will provide you my Google Scholar and information where you can find about each project in detail. So to go deep on this project, it's better that you refer to the publications. This is another nice project working with an organic farmer, which the goal is to detect 3 classes of cauliflowers: overripe, ripe, and non-ripe cauliflowers. So this is important to this organic farmer because he has a team of people. He needs to, for a matter of logistics, he needs to divide the work by the employers, but at the same time, he needs also to keep an update of the status of the crop. So because overripe cauliflowers is a product that we cannot sell on the market. In this project in concrete, we use another deep learning technique called mask RCNN. Again, all these works have been published, so you can have more technical information and specific information there. Another nice application, and also working with our neighbors, the Germans, is an application. In this case, okay, we have jumped from the cauliflowers, and now we are in the last crop, that is grasslands. In grasslands, in reservoirs, you cannot. There is a problem, and the problem is called that you have poison weeds. These weeds are very dangerous to the animals. Many of them die every year, horses, cows. So there is the need of eliminating these weeds from the grasslands. Currently, it's very difficult to deal with this problem, mostly because grasslands are in protected areas. So you cannot really apply chemicals or go there with mechanization or so. Actually, the current solution is a person that scouts all the grassland and applies plant by plant a chemical component. So in this study, what we did is we used the drone and we have provided to the farmer that is applying chemical plant by plant at the plant level a fine map with the location of the weed patches. A next step will be to have a drone, a spraying drone that go plant by plant, applying some hot water or a biological product that could eliminate these plants. For what autonomous flying concerned, there is also tons of work with the food safety research from Wagner University. Mostly we are interested in using drones with electronic noses to detect volatile organic compounds that are harm the human health in the food. So these derive from many things. I'm not going to give the large story. The short story is that, for instance, if there is a fire, there are like nanoparticles that fly around. They go to the crops, and then, of course, they are hard to eliminate just by washing it, and they are nocive for our health. So we are using M200 to do this experiment shipped with the electronic noses. This is also a collaboration with several universities. And in this experiment, actually, the drone goes autonomously, doing some patterns and mapping a determinate area. This is a video that we did last year, if I'm not wrong, or 2 years ago, where we use the drone to fly around of a tractor emission and to measure NO2. We are doing this because, of course, again, before flying and acquiring image, there is still a large process of sensor calibration. And these usually are the first step, calibrating the sensors. So we make sure that we have the reliable data. And it's not just about detection, because those are electrochemical sensors. So the output will be a voltage, but then we need also to convert this voltage in particles per million, that it's ppms, that actually gives an exact value of the amount of chemical that we have in a determinate site. This is also done with ROS. Another and final application in autonomous flying is indoors, flying indoors. For plant phenotyping, we are using 2 types of drones in this moment, also with robotic operating system. The drones fly over the plants on the greenhouses to obtain volumes, areas, and other phenotypes from these plants. We are also combining these with information from the employers of the greenhouse to train a model that is combines UAV data with also, let's say, low resolution data from mobile phones. Although today, most of the mobile phones, it's not a mobile phone, it's a camera that you can make phone calls. And this is a very interesting project with collaboration with also with the universities in the UK. And the results are quite promising. In this case, we don't have yet the publication, but hopefully it is going to come very soon. Finally, if you want to know more about drones, please enroll in the course Drone for Agriculture. It's free of charge and it's nice, with nice lectures. You'll learn lots of things about drones on agriculture. Unfortunately, this year is not possible anymore. The registration is closed. But in January is going to open again and you can register. So this is composed by 3 models. You can also read more on the FAQs about the course. I also would like to say that it's supported by IEEE Robotics and Automation Society, from ROSIN project that is funded by Horizon 2020, but also these courses are also supported by Wageningen University. Finally, thank you very much for listening me. You can find more information about me on my webpage, also in my Instagram, I love field robotics, in LinkedIn and in my Google Scholar. I would like to also say that if you want to follow us, the Social Artificial Intelligence Lab, you can follow us on Twitter. Thank you once again, and please let me know if you have questions.